Uh, nice picture, Or. It's possibly going to happen actually with my kids at home. Uh, so, so let's go ahead and begin. Uh, we are recording this meeting. One thing, I would suggest if you don't have your microphone muted, go ahead and mute it. But please go ahead and unmute it for if you have questions. If you have questions and you need to stop me at any point. And then what we'll do is we will this recording will automatically get saved to the Microsoft Team group and to the stream channel. Uh, so what I'll do here is let's go ahead and I'll share my screen here so that we can let's see, and everyone can hear me, I'm assuming, right? So if someone can either write something in the chat and make sure that you can hear me, let's go ahead and get started. All right, great, thanks, All right, so basically what we're going to cover today is we won't be on here for very long, or at least I don't plan on being here for very long, because it's really it's in a sense we're talking about testing, and this is also a test for our system, for our online classes. So we're going to just test it out and see how well it works. So what we're going to be talking about today is we're going to be talking about testing and how to test in Java especially. I've uploaded just before this class started, I uploaded a set of slides that comes from my software engineering lectures that is an expanded discussion on testing for those of you who may be interested in knowing more about testing and how testing is important. Just kind of a background, this is actually one of my favorite topics. I may have talked with you guys about that before, that my background, my undergraduate and master's degree was actually not in software, was not in computer programming, but was in electrical engineering. And then my first job actually was as a tester, was as a software tester. And part of the reason why I got that job was because I wasn't a software developer, and so therefore what the company wanted me to be able to do was to be able to test, not thinking like a programmer. So testers generally are not programmers' best friends. We generally, software developers don't like testers because one thing that many people tend to get confused about, many of us software developers get confused about, is we think that the purpose of testing is to prove that our software works. But in actuality, the purpose of testing is not to prove that something works. We can't usually prove that it works. All prove that we can't find faults. Doesn't mean that they're not hidden somewhere, doesn't mean that they're not there, it just means that we haven't found them yet. So actually the purpose of testing is to find places where the software isn't working. And generally there's going to be three places that testing happens, and one is the software developer. So when you are a programmer working on a system, you will test your own code. You will come up with your own tests, and if you don't test it thoroughly enough, then usually if there are problems in the code, it gets found at the next level. The next level is going to be what my first job was the quality, what we call the quality assurance section. So this is where testers, their job is to try to find problems with the code, and so if the error gets found there, then that's okay. The kind of the frustration becomes then we have to tell the programmers, hey, this is the problem that we found, and this is what you need to fix, or this is the way that it's a problem. And then the software developers fix the problem, we run the test case again, and we see if it works this time. Then the third place that errors can oftentimes get found, and this is the one that our companies do not want to have happen, or want to have happen as little as possible, is when users find our problems. So Usually, what this results in is a patch of some kind. So if you've ever been working on a computer, if you've ever been doing something, maybe writing a term paper for your English class or for your history class or whatever, and you get this little message that pops up saying that your system needs to restart because an important patch has been pushed to your computer. That's probably a result of some user out there who's found a problem, reported it to Microsoft or to Apple or to whoever, and then they've fixed that problem and pushed a patch out to your computer. And so the most costly in terms of time, in terms of money, the most costly place for us to find errors are when the users find our errors for us. So what we'd like to do is we like to minimize that as much as possible. So we'd like to run our own test cases in-house and make sure that we can test pretty thoroughly. Okay, so we'll talk a little bit about kind of the general idea of testing. Like I said, there's an expanded discussion set of slides on testing that I've uploaded. And so if you're interested, take a look at those. But I do want you to at least understand how to write Java test cases using JUnit. Okay, so if we kind of go through what we're talking about, what is JUnit and how to create a JUnit test class. The example that I'm going to show, the examples that I'm going to show today, I'm going to use my favorite program, JGrasp, for Java. You can run JUnit test cases in any IDE, NetBeans, IntelliJ, whatever you happen to be using. Basically, the idea is how to write the JUnit test cases is what we're going to be talking about today. All right. So JUnit basically is just a library for Java files where we can write test class. One of the things that the last time that we met, the last time that we got together, we talked about this whole assertion. So JUnit uses assertions for how to execute their tests. Okay, so remember, if you remember, and we'll look at the, we'll go back and visit the assertion demo here today. But if you remember, assertions basically are ways to kind of generate an error, to generate an exception in the middle of code, where just basically if the assert Boolean condition, we pass it a Boolean condition. If it's false, it asserts, it stops the program, it generates a runtime error. If it's true, it just skips over the line as if it wasn't there. And so that's basically kind of what we're wanting to do with the JUnit test cases. But in this situation, what we want is we want there to say, hey, if an exception happens, instead of ending the program, what it's going to do is it's going to say this counts as a failed test case. And then it's going to continue on and it's going to do the next test instead. Okay. All right. So let's see. So these slides are all available. Go ahead and download this. At present, the latest version is JUnit 4.10. That is still true. I went and looked on it today. This has not changed in almost 10 years. They haven't made a new version of JUnit. It still works. It still works with the latest version of Java. So go ahead and get this going on your system. If you have any problems, contact me. We'll try to work through as well as we can online of how to get this thing working for you. But I do want you guys to go ahead and have this running, because the next assignment will not be writing new classes or new functionality to your existing store assignment. Instead, it's going to be showing how you can test assignment 2. So you're going to write test cases for assignment 2, as well as something else that we'll talk about. Okay. All right, so go ahead and get it going. So basically, the way that we write a JUnit test class with test methods, so we're going to import these different, if you notice the whole assert, so it's a JUnit assert class that we're going to be package that we're going to be getting. All right. So we basically write some different void methods, right, that run a test case. And when we run this, when we run our test class, what's going to happen is it's going to treat each method as its own test case. Okay? So it's going to run the method. If it gets through the entire method without seeing an exception, it counts that as a passed test case. So we can test multiple things inside of here if we want, but it will only count as one test case when we see our results. And then we could also, what may be a better idea, would be to break out different functionality across multiple test methods so that each thing we're trying to test becomes its own test case. Okay. By the way, this is just an example of how you would write these. As always, M1, M2, these are not good method names. There is no one way to write method names, but I would say that generally speaking, the way that I learned when I was writing my test cases, when I was learning how to do this, is each method name would have a name such as TC001 underscore and then a description of test price, for example. Okay, so this way we're saying, okay, this is a number for the test case, and then this is a name for just a short description of what we're trying to test. Okay, and then maybe what we could do is this first number here, this first 0, could be kind of a category. So like, let's say in our store example, we had the store class, we had the product class, we had different children of the product class. So maybe the store might be 0, and then the product, if we're testing the product class, we could say that's the 100 level test cases. And then if we're testing the customers, that would be the 200 level test cases, stuff like that. Okay. Again, that's just the way that I was taught how to do these things. It doesn't mean there's only one way. You can name your methods anything, but as always, this method name have to be different because this is not that way it gets seen as two separate methods. If we name them the same thing, we'll get a compiler error, as you would expect. Okay. All right. So then we can run the test case. You can also just, in most IDEs, you can click the run button. I'll show you something about that in just a moment as well. And so the example, so what we'll do is we'll just look at this example, this test array list example, and then we'll also use another example that's from the lecture examples as well. Okay, so let me move over to JGrasp. Actually, I think I shared just the PowerPoint, so. All right, so you should be seeing my JGrasp now. All right. I'm assuming you can see it well enough since it should be on your computer screen, and I don't need to increase the font as I normally would. Okay, let me go back and close this for a second, because what I want to show you is that in this testing of the array list, for example, all right, if I were to compile this, it should compile. Yeah, it will compile. But if I go to run this just as is, okay, if I were to run this as is, right, it'll tell me there's no main methods, there's no applets, there's nothing to run. I don't have a main method to run. One of the things that JGrasp requires, and to be perfectly honest, I have not tried using this in any other IDE. I haven't tried using it in like the IntelliJ, NetBeans, or Eclipse. So I don't know if, just off the top of my head, if there's something, if there's a way, something else required in those IDEs. So let's see. Where I was getting at is in JGrasp, in order to run this as a test, I have to add it to a project. Okay. And by adding it to this project, by this JGrasp project, right, then it understands based on the way that this is formatted, based on the way this is done, that oh, this is a test file. This is a set of test cases. So notice the compile button, the run button, the debug button, they all changed a little bit, right? So if you see this again, let me close it all out. All right, so notice the green, this button is green, this is red, this is a red ladybug looking thing. So if I open it as a project and it recognizes this as a test class, suddenly those buttons change a little bit. So now this is saying, oh, I understand this to be a JUnit test now. So if we compile this, it'll compile just like before, compile, and now it'll run. And when I run it, it tells me I got 2 tests and 2 passed. We'll step through just a moment about that, but I want to go back to the assertion demo as I said I would. Okay. So any questions so far about what we did with the slides before we get too into the weeds with the examples? Okay. All right, just stop me as usual. Just stop me if there's any problems, okay? All right, so the assert, remember the assert idea is if the condition is true, then it just skips over it as if it wasn't there. If it's false, as this one we'll see in just a minute will be, then it will display this message. It'll generate an exception, a runtime error, and it will produce this message. Okay, so this is the basis of what a test case is all about. So if I compile this, and if I run this, okay, now notice that it generated an exception because sum was 45, which means it was greater than 10, but it was not less than 20, right? So this was false. So even though this part was true, the and said because this other part is false, then true and false is false. So then assert, if it's false, I'm going to display this message. And notice it generated an exception, an assertion error specifically. It displays this message as part of that. Okay. And then it doesn't do this. It does not print this. Okay. Now the assertions, we can throw them in there as ways to test our code, that then all we have to do, if once we figure out that this assertion is not a problem, if this is not the kind of error that we want to display, that if during running we want to say, okay, during testing we want to know this happened, but during production, during when this code is actually out being used by users, we don't want them to see this error. What we can do is we can disable assertions. So here I've taken the enable assertions off. So now if I run this, notice it just skips over it now. Okay, it just doesn't even look at this anymore. Okay, it treats it as if this line didn't happen, and it's instead skips right over it and displays this here. Okay, so this is useful for if we're wanting to test something in particular, but then once we build it and send it out, that we can just have the user's version of this code just skips over it. Basically, this is probably something that if you've ever seen an error message that you shouldn't have seen, where maybe even the message says the user should never see this, there's actually, you can find those screenshots on different tech websites and stuff of people making fun of code that's out there. It's probably an assertion or something like that that was left in the code, and the programmer or the tester forgot to take it out before they put it out to production. Okay. Let's see, do I have a question over here? Okay. Okay, let's see. Where were we? Let me go back. All right. All right, so that's the basis of the assertion. So that's kind of the assertion is the basic understanding of assertions is helpful in understanding how these now work, how these test cases now work. Okay, now this whole setup thing, right? So right now this has no code in it. This is a useful method that we can use to start stuff, to set things up before our test cases. The thing is that notice that each of these, right, methods, test insertion, test deletion, they're just methods inside of a class. They're just it's a public class called ARRAYLIST test, right? And it's just a few void methods. Each of our test cases is a void method inside of this class, which means that there is no definite order that these are going to be run in. So we don't get to control the order that these get run in. It could run this one first and then this one. It could run this one first and then this one, right? And it may be different from time to time. It may be that one time I run it and it runs it in a certain order, and then another time I run it and it's a completely different order. But this method, if I have it included, right, if I have it this format right here included, no matter what, this method will get run first. And it's so that if we wanted to set up the string array list to have certain values to start with, okay, we would go ahead and put that in here, and then for each test case, it would then start with that. Okay, so, all right. So let's take a look at how this would work. And what we'll do is we will set a couple of debug points so that we know that we can debug it along the way, so that we can see what happens along the way. All right. So when we debug this, okay, so we're just gonna, so here, now, there's a couple of different assert methods that the JUnit package gives us access to. Okay, so one of those is the assert true method. Now, what this does is it says, okay, if this is true, then this will not assert. Now, I know that that sounds the opposite. Okay. So basically, the way that the assert methods are set up is that I want to assert, but if there's a problem, but this part true, that's what I expect it to be. This is what I want it to be. I want this to be true. So list dot is empty should be true, right? Because we start with an empty list. So if it is true, then I'll pass along, I'll just continue along as if there's no problem. Okay. If it's not empty, if this is not true, if this is false, then it will assert, it will generate that exception, and it'll keep on, and it'll stop right there, and it'll count as a failed test case. Okay. All right. So we step over because this list, it is empty. There is nothing in it. And so I will not assert anything. Okay, I will not generate an exception because this was what I expected it to be. So now I'm going to add some different values to my list. All right. All right, so we should be able to see A, B, and C. All right. Now do this. Okay. Now let me explain the assert equals method. Now the assert equals, just as the same over here, is it saying, okay, if the first value in the method is equal to the second value in the method, then this counts as a pass. This counts as a, so I will not generate an exception if they're the same. So what's the size of the list? Should be 2, right? Because we had 3 values added, we removed 1, and so now we should have a value of 2. So if I step over this, all right, okay, so I got through the entire method with no exceptions, right? So that should count as a passed test case. So let me skip on through to the next one. So notice now I have one passed test case. Okay, I passed the test deletion. So I was able to delete something from my array list. Okay, now I want to test the insertion method. So I added Beijing, so now my list should have, right, nothing besides Beijing in it. Is the first item, right, so the first item I get, Beijing, is it the same as this string Beijing, right? It was true, right? It did equal. This did equal Beijing. Now notice something. We used the same method, assert equals and assert equals, right? But notice that this was a string and this was an integer. That's okay. The cool thing about the assert equals method is it tests for equality. It's not the double equals, right? So assert equals does not do this, right? It doesn't do the double equals because remember, these would not be the same in a doubles equals. It tests for do they have the same value? Okay, so that's a cool aspect. We don't have to have an assert string equals, assert integer equals, assert double equals. We don't have to have any of that, right? We just have to have this one method that whether I pass it a string, an integer, any other data type, it will tell me whether or not they have the same value. Okay. All right. So now we're going to check. We're going to add Shanghai. We're going to add Hong Kong. And I just realized these are all Chinese cities. Okay. Anyway, so that's kind of funny. Now we're going to see, does the last value in our list, we're going to get the last value on our list, does it equal Hong Kong? And it should be okay, it should be fine. So we step over, no exception, and we just resume. Okay. Now, the reason why these pass, and I want you to notice something else that happened in this, was that even though test insertion shows up first in our class, test deletion was the first one that got tested, right? So it was tested out of order, but that's okay because basically it's just going to run all of the test cases in our class, okay? And remember that the only thing that it's trying to do is it's testing is there an exception, okay? So if we wanted to write a new test, okay, if we wanted to run a new method that was just don't do anything, okay, do that, and we run it. Now we have 3 test case passed. Okay, this would not be a very ethical way to run our tests. Okay, because we could have just a bunch of empty test methods that don't do anything, and we could say, hey, we had 100 test cases and all 100 passed. Okay, but that would not be good, right? That would not be what we are trying to do, right? And any exception. Any exception generates a failed test case. Okay, it doesn't have to be a specific type of exception. Any exception that comes here, notice it doesn't stop our test because notice the test blank here, it was run second. So the way that the tests were run here, the order they were run in, this one was run first. Then this one was run, and then this one was run. And notice that this exception did not stop my test cases from running, did not stop this one from executing and completing. All that it did was it said, hey, this resulted in an exception, so this is going to result in a failed test case, what's viewed as a failed test case. Okay. One thing I want to go ahead and add to our discussion here is I would generally advise you not to have multiple assert statements inside of one test case. The reason for that is notice that, let's say, okay, let's say we did this, okay. We compile it, we run it, okay. Now notice test insertion failed, right? Test insertion failed because we expected Beijing, but we got Beijing, right? Okay, so we ended up with a failed test case. Here, if we do it this way, right, we end up with, okay, same problem, a failed test case. It does give us a little bit of information with the Hong Kong versus the Hong Kong without the G. So it does give us some information, but the problem here was that unless we go back and look deeply into the test case, we don't know what the error was. If there's multiple assert statements, all we know was that an exception happened sometime during the running of this test case. Generally speaking, I would say the way that you want to write test cases is you want to write what you expect to happen, and you want to have an assert statement at the end. You want to have some assert statement at the end of the test case that represents whether or not all of the code before it passed or failed. Okay. All right. So this is an example of how we can use assert statements. So let's I need to change the dates on this, so I'll do that before, when we end this recording. Okay. So let's look through kind of a real example of how we might use this. Okay, so here we have just a simple set of classes representing a university and courses. Okay, so here a university a university is going to have a set of courses, a set of students, right? So when we create our university, when we use our constructor, we'll give our university a name. We'll have the get name method. Okay, we're going to have an add course method to our university so that we can add courses to our university. And that simply we'll pass it a course, C, and we'll add that course to our method. Okay, so we'll come back to this one in just a moment. Okay, we'll come back to this in just a moment. So, by the way, if you guys have a question, you can just write it here into our conversation, right? Or, okay, so you're asking test cases are all about the assert statements, or do we use Boolean or other statement for the test process? Okay, kind of both. So let me go back and talk about how these test cases are run over here. Okay, so let me go back to this one. So the assert statement is kind of the basis for how the JUnit assert class is done, right? So the assert statement, if we look back at that for just a second, all it does is if this is true, it does nothing. It just skips over it. If this is false, then what it does is it generates an exception. It generates an exception and it produces this message as part of that exception. Okay. Now, if we look at the assert equals method, that would be part of the JUnit assert class. Okay. Then what's inside of that method basically is it's saying assert, this is the equivalent of assert. Let me just copy it so I don't type it wrong. Assert Beijing equals right. So basically this and this are kind of the same thing. Okay, I don't know for sure. I don't know the inside of the assert equals method, so I can't know this for sure, but this is what I imagine is going on inside of there. Okay, and so what's going on is it's saying if this is true, do nothing, just skip over it, kind of like this one did here, right? If this is false, then I want to generate an exception and stop this code where it's at. Okay. And again, when we run this as a test case, when we run this as a test set, then what happens is the exception stops this method from running, but does not stop my my test suite from executing all of the test cases there. Okay. In fact, let's go ahead and test this out. Let's see here. So if we compile it, let's see. Oh, I need a semicolon here. Okay, let's go ahead and compile it. Okay, and run it. All right. So notice, okay, test insertion passed. Right. Let's see what happens if we let's leave this one as it is, and let's take this one off. So this should result in a failure of a test case, right? So this should result in a failure. Okay. And actually, it went ahead and generated an exception, did not do it here. I wonder if, let's see, it doesn't let me do the enable assertions over here. Okay. It must be, okay. It must be that for a test, a JUnit test case class, it must not allow me to do the enable assertions over here the way that it did in the other one. All right, so I have no way to test that. All right, but it still holds that I would imagine that something like this is what's going on inside of here. That this code inside of here is that if these two are not the same, if they do not have the same value, then it is generating an exception much like this one is. Okay, because it did not generate the exception. So I'll leave that there, and it should run now. Okay. Yeah, and this exception that's running here is this. This exception that's down here is showing this right here. Okay. All right. Good question though. Good question for clarity on what is going on with the whole assert thing here. Okay. So let's go back here to our course stuff. So our course has some different information for its constructor, the get name method to be able to get the name of the course. And obviously, if we were developing this thoroughly, we would have a bunch of other stuff here in here as well. Okay. And then we'll have also just the class student as well. Okay. But really what we're going to test right now is going to show how we would test. Okay. What we're going to do is we're going to show how we would test whether or not we were able to get the name appropriately, right? So we're going to test a couple of different, like, can we set this to the new university gets this name? Can we create a different university with a different name? Okay, and then we're going to test the add course method. Okay, so let's just show, comment these out. If I have my test cases for the university name. Now remember, if I try to just compile this and run it as is, it's going to tell me there's no methods or anything. So for JGrasp, remember we have to put this into a project. Okay, so let me close this. And for those of you who use JGrasp, let me go ahead and I'll start from scratch. I'll start from the beginning here, and I'll delete this project, and I'll show you how to create a project. So basically, there's a project tab up here. Okay. So we can create a new project. Yeah. Right. We can add files to our project. Okay. And we're going to add this one here, and we're going to add this one here. And done. And now notice it's automatically figured out that this test file is a set of test cases for this other file. Okay, so it already has figured that out. Okay. Another cool feature of JGrasp here is if we want to see what our UML diagram, so notice that our university has a set of courses, has a set of students. So if we want to see what our UML diagram would look like for this, notice that okay. All right, so our university has a set of courses. Now, the reason why there's no similar reference line between university and student is because if we go back and look at our source code here, we have this array list here for students, but it was never initialized. Like we never have a place that we actually use that to add students to it, and so we would have to add that code in order for it to show up here. Okay. All right. So let's get continuing here. So in our test case, we're going to create a university and we're going to test the get name method. Okay. So we compile it and we run it, and we should see that we have two test cases passed, right? Where we gave it this name, we got that name. We gave it this name, we got that name. Now, what if we want to change the name of the university? What if we want to set the university name? Well, right now we don't have that as a method, right? So there's a type of development that if you look at the additional slides, the other set of slides that I've posted, it talks about what's called test-driven development. And what test-driven development is it says, I want to write the test cases before I write the code. Okay. So let's say here we wanted to test get university name, and here we want to test that we can set the university name after. Okay. Now, what's going to happen is what's going to happen is when I go to compile this, it's going to tell me that there's a problem, right? Because why? Because this method does not exist. Okay. All right. It says I can't find set name in the university class. And that's what we would expect. That's what test-driven development is all about, is we write the test cases first. We expect them to fail because they should not pass because we haven't done the work of the method yet. And so then what we do is we say, okay, we don't have that method. We're going to write the method. We're going to take the write type. Okay. Now, this compiles. This compiles now, right? Because now that method exists. But again, this test case should fail. And the reason why this test case should fail is that this method does not do what it's supposed to do yet. All right. Okay. Now it's going to say, oh, that failed. You did not set the university name appropriately. All right. So then what we do is we go back again. We say, okay, now I'm going to make the code do what it's supposed to do so that when I compile this and I run it, good, now I have a passed test case. Okay. All right. So if we walk through another example here, the add course method. Okay. So the way that we would start off with that is we would start off with no method. This would be if we were doing this through the test-driven development format. Okay, so what should the add course method do? We should be able to create a university. We should be able to add a new course to our university, and if this does not equal this, then we should generate this message. One thing I just realized was we did not talk about this aspect of the assert equals method. So in this first one back here, assert equals, if we pass it two parameters, only two parameters, it just tests, does the first one equal the second one? Does the first one and the second one have the same value? Okay. If we give it three parameters, a string plus two more parameters, then what it does is it says, does this equal this? And if not, I want to show this message. Okay, that's very helpful for us to understand what was the problem. Okay, so like for example, we might say, okay, let's not correct, university name not correct, university name not correct. That's not very descriptive based on the test case, because what we can do is can say not correctly set in construction, right? And we could say this is not correctly set in set name, right? And so now what we've been able to say is that this special message is going to be displayed so that we give ourselves, our testers, our programmers, a little information about not only what was the name of the test method that failed, but also some extra information about what was going on. What were we trying to do when that failure happened? Okay. So here, course not added to the university. If we go to get a specific course, we go to get this course, and we go to get its name. Okay, what is its name? Okay, so if we compile this, it's going to give us an error because the add course method does not exist. Okay, so the add course method is a void method. Right. So now, okay, if we go to get this course, right? So we're going to compile this. And if we compile this, it should compile fine this time. But now what's going to happen is when we go to run it, you should get a failure, right? Why did it fail? Well, let's see. It failed because when we tried to get the course, all right, it tried to get a course from an empty set because we never added it. Right, it tried to get the first course, it generated an exception, and it's going to tell us that the course was not added, right? So, so what we need to do is now we need to modify. Okay. So now we're going to add the course, we're going to get the course, right? We're going to compile it. and we're going to run it. Okay. Now the test passed, but as I said before, we cannot prove that the system works just because we have passing test cases. And this is a really good example of a system that does not work, that does have problems in it, but we have passing test cases. Okay. The add course method, there's not a problem here, right? It's pretty simple, pretty straightforward. We're adding the course that we're passing to our array list. Everything should work fine. The problem is in the get course method, right? We're always returning this first one. So what we need to do is we need to refine our test. So we need to refine our test case, and we need to add another new course. So we're going to add, we'll add my other course to this, okay? We'll add my database class. Okay. Instead of 120 students, we'll say we can have 50 students in it, for example. Okay. Now, we're going to change this to 204, and we expect that the course name would be 204. All right. So now, we're going to change our messages. All right. So that this will tell us more information about what failed. All right. Now, this will give us an error again because, one of the things I said before was these methods cannot have the same name. Okay. So easy fix is we can change what number of the test case we're doing. Okay. So when we run, we should get a failure on this one. All right. And the reason why this one failed was because I got CSE 102, but I should have been getting CSE 204. And the reason here why is because in the get course method, I always just get course 0. I always just get the first course in the array. Now, could we fix that? And we say, oh, you know what? Let's do this. All right. Now, will that pass my test case now? And for those of you who are saying yes to your computer screens, then you're right. Of course, it passes my test case. Why? Because now the first value in my array list is now the value I'm looking for. But just because my test case passes does not mean that my code is working. In fact, it's not. In fact, what we're trying to do is not correct here. Instead, we need to modify this get course method so that it does what we are actually expecting it to do. Okay, so this is some examples of how the test cases, if we write them appropriately, if we write good test cases, then failing test cases is not the problem. We don't want to make our test cases pass. We don't want to change our test cases so that they'll pass. What we want to do is we want to write our test cases so that when those test cases pass, that we have a lot more confidence that our code is doing what it's supposed to. Okay, I won't go into this one on this live lecture, but I did upload a video, and it should be at the YouTube channel, and it should also be on the Microsoft Stream. What I talked about was what we call partition testing or edge testing, and the idea is about where you have some border conditions where something goes from, for values less than a certain amount, our system does something. For values that are greater than a certain amount, our system does something, and we want to test those edge conditions, and we want to test things from the middle of those conditions. So I encourage you to watch that video, but one other type of aspect of testing that I want to go through before we end our time here today is I want to talk about what we call coverage, code coverage and functionality coverage. So basically what the idea of code coverage is that we want to make sure that our test cases cover every line of code in our system. Okay, now that doesn't mean that we can test every possible input. That's not what we're saying. In fact, it's not possible to do that. Google, Amazon, those guys, they cannot test every possible input that they may ever get into their search bar, right? It's just way too much, and it would take way too much time. So what we want to do is we want to make sure, one of the things we want to make sure is that we can test such that the way that we phrase this is that every line of code is executed at least once. So what that means is that if we have an if statement, okay, so if we have, let's see, so like a set name here, so the set name for the university, right? So if we had, or actually, let's put a new method down here on the course, because I think the count would be a better example here. So maybe we want to say, okay, we want to have a new method to set the count for the class. This count represents how many students can be in the class, right? So what we want to do is we want to say if count n is less than 0, okay, we want to do something. What do we want to do? Do we want to have an exception occur? Do we want to display an error message? You know, what is it we want to do here? It's whatever, okay? I'll just kind of do this pseudocode style here, right? So maybe we might say here, throw new exception, right? Okay, and maybe this might be a what is it? A custom exception, a custom made exception, like for your assignment 2, for example. You might have like a throw new invalid count exception or something like that. Okay, so what that means is that for testing purposes, we want to have at least one test case where this line gets executed. This would be considered the normal execution. This is what we expect to happen. So we want to have a test case where this actually happens. Then we want to have at least one test case where this happens, the exception, where the exception gets thrown. Okay, and that would be what we would call, we call that either path coverage, or we would also call this code coverage. All right. Now, does that mean that we need to have multiple test cases? Do we need to have a test for a count of negative? That we need to have a count of 0, 1, 2, 3? Do we need to test all these different values? No, right? We just need to have one test case. In order to have code coverage, we need to have one test case that executes this line, one test case that executes this line. Okay, so that's what we would call code coverage. So what about loops? Well, a good example of a loop would be this one here, the get course, right? So how would we go to get the course? Okay, well, we don't want to get the first one. That's not the correct way to get the course, right? Because what we want is we want to get the course that has this name. So one solution might be something like this: for course in, what do we call them, courses here, right? Okay. So for the courses that are in our array list, if c dot get name dot equals name, right? So if the name for the course C that we're currently at in the loop is the same as the name that we passed, then that means what? That means we found the course we were looking for. We can just return C, right? Okay. So what should happen if we don't? What happens if we don't get to here? Right? What happens if we don't return C? Then we could probably, in that case, throw an exception, right? Throw new course not found exception. Okay. So this is a loop. So in a loop situation, right, it means that we want to have at least one test case that goes inside of the loop, and we want to have at least one test case that does not ever enter the loop. Right? So we want to have at least one test case where we want to have at least one test case that does not enter the loop. Well, how would we not enter the loop? We would not enter the loop only in the situation where this was empty. Right? So we want to test the get course method with some value of name, right, where we haven't even added any courses yet. Okay, so this would represent that edge criteria where we have 0 courses. We have a university, we haven't added any courses to our university yet. So what should happen if we search for a course but we have no courses in it? Well, we should get an exception. So in this situation, that criteria, we're looking for a course, but we don't even have any courses yet, we would expect an exception to occur. So our test case would have to be written in such a way that an exception occurring there would not be considered failure. That would actually be passing the test case, right? Because the expectation is that an exception would occur. All right. So then we would also want to have a test case where we go inside of the loop. So for this particular situation, the get course method, we want to have a test case that never enters the loop, so our courses array is empty. We want to have a test case that enters the loop and finds the course. Okay, that would be considered the expected normal behavior. All right, and we need to also have a test case that is different. We need to have a test case that enters the loop but never enters this if statement. Okay, and that would represent the situation where we're looking for a course that does not exist inside of a list of courses. So we need to have a situation where we pass it a name. We don't have an empty set of courses. We have courses available to us, but that name does not appear inside of that array, that array list. Okay, so that would be an example where it enters the loop, but it does not enter this if statement. Okay, so those would be the minimum. So just for this one method that consists of 4 lines of code, we would need to have at minimum 3 test cases to be able to be satisfied that we had tested this method thoroughly. Okay. All right. I will plan on, if I would like some feedback on the video that I uploaded, the one that talks about the edge criteria. If that is something that you would like me to continue doing, where I kind of simulate, I used a tablet to simulate what the whiteboard would look like. If that's something that you guys found useful and found that was good to help explain the edge criteria, the partition testing, I could also do one similar to that for some other testing topics, like what we would call white box versus black box testing, and then also this whole path or code coverage. I could also show some kind of visual examples of how that would look. So if you guys can give me some feedback on the video that I uploaded, that would be great. And I'll do some more like that if that's helpful to you. Okay. If there are no questions, if there are no other questions, let me stop sharing here. Okay. If there are no other questions, and I can turn the camera on so you guys can see me too. So if there are no other questions, then what we can do is we can end our discussion here, and we can Actually, well, there is a question. During different cases, stopping testing. Let's see. Get a failed results. No, because it will run through all test cases as long as the exception that occurs. I guess if it had some kind of like system exit type of error or something like that, then testing could stop. But I would imagine that as long as it's just a normal exception, as long as it's then just that test case would stop, and then the rest of them would then continue on. Because basically what happened. Funny. April Fools. April Fools. Uh, okay. Uh, my favorite holiday. So anyway, yeah, my what I was saying was when the exception occurs, that test case stops and exits. It generates a failure. It generates a failure message for that test case, and then it continues on to the next one. Okay. All right. So if there's any other questions, we can have those now. If not, then we'll call this meeting to end. And I hope that this was not too uncomfortable. Okay. All right. So let's go ahead. This recording, Microsoft is done processing this video and uploading it. You'll be able to rewatch it on the Microsoft stream. I will also plan to download this, download it, and then upload it to YouTube as well. So for those of you who are following the YouTube channel, the playlist, the CSE 102 playlist over there, you should be able to view this. Hopefully, I'll have it up there by the end of the day. Okay. All right. Thank you guys for joining, and we'll do this again tomorrow morning at our normal time. We'll do a 9 o'clock like normal. Okay. See you guys then. Apparently, you have to leave the meeting, so in order for us to end it.